Okay, this time let's solve the following integral. We have e to power 3x sine 2x minus cosine 2x and dx. So let's first of all distribute e to power 3x. It's going to be integral e to power 3x sine 2x and minus integral e to power 3x dx and e to power 3x cosine 2x dx. So I'm going to write down it as e1 minus I1 minus I2 because I'm going to take by pieces and simplify it. All right, so first thing, what we're gonna do, I1 is, I'm going to work on I1. I can change this color so you will see. All right, integral e to power 3x sine 2x dx, okay, is equal. I'm going to do substitution, right? It is going to be, so I'm substituting with e to power 3x and dv, accordingly it's going to be sine 2x dx. Okay, let me move this to the bottom. So this is what is given. Now if u is equal e to power 3x du, it's going to be equal going to be equal 3 times e to power 3x, right? First we take derivative of e to power 3x, which is going to be 3 to power e the 3x, and then I'm taking derivative of 3x, which is going to be 3, and derivative of x, which is going to be dx. Now dv is equal sine 2x dx, which means v is going to be equal integral sine 2x dx, right? So real quick, I'm going to do another substitution here to get sine 2x, because instead of x we have 2x, so 2x is going to be y, which means I need to have here also sine 2x and d, I'm going to put here 2x, right? And since I multiply by 2, here I'm going to put 1 over 2, not to disbalance it. And this is going to be equal 1/2 integral, plugging substitution, sine y dy, right? And this is going to be equal negative 1 over 2 cosine y. So cosine y is going to be 2x, right? Which is equal negative 1 over 2 cosine 2x. Okay? So okay. So those are changes I made. Now from here, I'm going to apply the formula we know, right? The integral u dv is equal uv minus integral v du. Yes? So let's see, method of substitution by parts, integral by parts. So what we are going to do here, I'm going to have, so my u is e to power 3x. My v is negative 1/2. Let me clean here, put here. Negative 1/2 and cosine to x, right? Cosine to x, and then minus, we're going to have integral v. This is going to be negative 1/2. Let me clean this piece. 1/2 cosine to x. Let me write down here also it's v, so it will know. Okay, cosine to x times it's gonna be 3 e to power 3x and dx. So what do we have here? This is our du, right? And this is our v. Excuse me. Okay, so this is my v with this piece, and this is my u. Okay, so uv minus v du. Okay, next, it's going to be equal. So I'm rewriting the first term, negative 1/2 e to power 3x cosine 2x, okay, minus square root, square bracket. I am going to have negative 3 over 2. I'm taking this from under radical 3 and 2, 1/2, right? Negative 3 over 2 integral, and gonna be e to power 3x cosine 2x and dx. Okay, so what is gonna be my u? What is gonna be my dv? This is gonna be my u. This is gonna be my dv. So, and here we have u is going to be e to power 3x, and dv is equal cosine 2x dx. Okay, accordingly, du is going to be equal 3 e to power 3x dx, and v accordingly it's going to be integral cosine to x dx. Through the same substitution, it's going to be 1 over 2 sine to x. All right? Okay. So this is going to be equal negative 1/2. The first term stays the way it is, 3x cosine 2x, and then minus square bracket. I'm going to distribute this negative 3 over 2. Okay, well, let's open up first then. Negative 3 over 2. It's going to be u, it's going to be e to power 3x, right? And v, it's going to be 1/2 sine 2x, yes? So let me show, this is going to be my u, this is going to be my v, okay? Minus, I'm getting integral, we have to get v du. So v is going to be 1/2 sine 2x dx and times, well, yeah, I have to squeeze in also my du completely, times 3 e to power 3x dx. Okay, so let me show you. This is my v, right? And this is going to be my du. Okay? All right. So from here, let's simplify. I am getting negative 1/2 e to power 3x cosine 2x minus, next I'm going to distribute this negative 3/2 into two these terms. Okay, it's going to get negative 3/2 times 1/2, and then it's going to be e to power 3x sine 2x, yes, minus 3/2 integral, it's going to be, let me see, this 3/2 come out, so I have to multiply by this 3/2 coming out, right, times 3/2. This is this 1/2 and this 3, right? And here we are getting integral e to power 3x sine 2x dx. Okay, here I see I made a mistake. I have minus and I have negative 3/2, right? Okay, because we had minus and we're distributing negative 3/2. Okay, next we are going to have negative 1/2 e to power 3x cosine 2x minus negative 3/4. Actually, I can open parentheses, might as well. Nothing prevent me from opening parentheses. It's going to be plus 3/4 e to power 3x sine 2x and minus, why is it going to be minus? Because this negative with this negative, it's going to give me plus, right? And I have here another negative I'm opening, all right? So it's going to end up with negative. So it's going to be equal minus 9/4 integral e to power 3x sine 2x dx. All right, look what we got here. It's very interesting. I got here the original, see this piece? Integral e to power 3x sine 2x dx. And we got original problem, integral e to power 3x sine 2x dx. So it's practically the repetitive, it's getting into loop, which means I'm going to write down original one. So we have integral, my E1, right? That's my E1, integral e to power 3x sine 2x dx. I'm writing down this one, okay? And moving this negative 9/4 on this side, on the left side of equation. 9 over 4 integral e to power 3x sine 2x dx. This type of method we met also when we were doing implicit derivative. If you go back to go to topic derivatives, implicit derivative, you will see there also some similar thing. Okay, same strategy. So this is going to be equal negative 1/2 e to power 3x cosine 2x and plus 3/4 e to power 3x sine 2x. Okay, so we are getting here 13 over 4 e to power, I added this 1 and 9 over 4, so I got 13 over 4. So it's going to do e to power 3x sine 2x dx is equal negative 1/2 e to power 3x cosine 2x and plus 3/4 e to power 3x sine 2x. Okay, from here we are going to divide by 13 over 4, right? The whole this equation, and we are getting integral e to power 3x sine 2x dx will be equal negative 2 over 13, because negative this 1/2, when you divide by 13 over 4, you get negative 2 over 13 e to power 3x cosine 2x and plus 3/4 now divided by 13 over 4, it's going to be 3 over 13 e to power 3x sine 2x. So we got this part I1. Okay, now next moving to solve I2. Okay, now let's solve I2. For I2, we have integral e to power 3x cosine 2x dx. Let's do substitution. We are taking u is equal e to power 3x. Let me move a little bit down. Yeah. E to power 3x and dv is equal cosine 2x dx, right? Here. So from here, du is going to be equal 3 e to power 3x dx, right? And v, accordingly, just like I did the method of substitution in first calculating I1, it's going to be 1 over 2 sine 2x. Okay? So this is going to be equal, let's plug in my u and v. I'm going to use again integral u dv is equal uv minus v du, right? By parts. Okay, integration by parts. So this is going to be equal 1/2 e to power 3x sine 2x, right? This is my u and v minus this is my v and this is my u, right? So minus, it's going to be integral v du 1/2 sine 2x times 3 e to power 3x dx, right? We used v du. Okay, now, next substitution we are doing here, it's going to be u is equal e to power 3x and dv is equal sine 2x dx. And we get here du equal 3 e to power 3x dx, and v is equal negative 1/2 cosine 2x, right? Integral sine is negative cosine. Okay, so this is going to be equal 1/2 e to power 3x sine 2x minus, it's going to be 3/2. I'm taking out this 1/2 and 3, and it's going to be 3/2 square bracket negative 1/2 e to power 3x cosine 2x, right? This is going to be my v, and this is going to be my u, right? Okay, minus integral negative 1/2 cosine 2x times 3 times e to power 3x dx. All right, next is equal 1/2, the first term coming down without any changes, sine 2x. Now minus 3/2 negative 1/2 e to power 3x cosine 2x minus, well, it's going to be plus because I'm taking 3/2 here out, right? It's going to be plus 3/2 integral e to power 3x cosine 2x and dx. Okay? All right. So from here we are going to have 1/2 e to power 3x sine 2x, again with no changes. This is not going to change anymore, this term. Now it's going to be, I am distributing this negative 3/2 by here and here, and we are going to get plus 3/4 because I have negative 1/2, so it's going to get positive e to power 3x cosine 2x and minus 9/4 integral e to power 3x cosine 2x and dx. Okay? So, look what we got. We got here our original problem. Look here. Yes? Therefore, I'm going to write down integral e to power 3x cosine 2x dx, right? My original one, because all this thing, expression, is the part of equation, and it's equal to integral e to power 3x cosine 2x dx, right? And moving this one to the left side of the equal sign, it's going to be plus 9/4 integral e to power 3x cosine 2x, okay, and dx. And this is going to be equal, what we have left, this piece, right? This piece is going to left. So we get 1/2 e to power 3x sine 2x and plus 3/4 e to power 3x cosine 2x. Okay, so I'm getting from here, this is 1, and here I have 9/4. It's going to be together 13/4 integral e to power 3x cosine 2x dx, and it's equal 1/2 e to power 3x sine 2x and plus 3/4 e to power 3x cosine 2x. Okay, so once we divide by every single term by 13/4, I can write down this way. So result is going to be integral e to power 3x cosine 2x dx is equal 2/13 e to power 3x sine 2x and plus 3/13 e to power 3x cosine 2x. Okay, so this is our I2, right? We solved. So from here, let me write down my original integral, if we haven't forgotten. Integral e to power 3x, we had, let me redo this integral, to power 3x, sine 2x minus cosine 2x dx. Remember, we wrote down it was equal I1 minus I2, and that is going to be equal, my I1 is, let me see, this is going to be my I1. This whole expression is my I1. Negative 2/13 e to 3x cosine 2x and plus 3 to 13 e to 3x sine 2x. Okay, let me write down. This is going to be equal negative 2/13 e to power 3x cosine 2x plus 3 to power 13 e to power 3x sine 2x minus, now we need to subtract I2, right? In here we have I2, so minus 2/13 e to power 3x sine 2x and minus 3 to power 13 e to power 3x cosine 2x. All right, let me do it more organized, move it here, and this here. Okay, this is much better. So this is going to be our I1, and this is going to be our I2. Okay, and this is going to be, from here we are going to have, let me add here also C, constant, right? Because we never know what constant can be, and since the derivative of constant is 0, that's therefore from under integral always has to come out also C. And this is going to be equal, once we combine like terms, cosine 2x, cosine 2x, sine 2x, sine 2x, and e to power 3x, I'm not counting because it's everywhere. Every single term has it. So it is going to be 1/13 e to power x, and in parentheses I will have sine 2x and minus 5 cosine 2x plus c. And that's all. Well, since this integral was kind of long, how to solve it, therefore I'm not going to add here any other integral, so you will have time to go over and digest. And I will continue solving more integrals in my upcoming next videos. Okay? Thank you for watching, and put a comment please under the video. Okie dokie.